I would like to propose that, although it may be difficult to consider the impacts of such technologies in the way that Horst has put out so well, we still should do it. And there are some amazing innovations that we can create and produce through towards a national collection. I'd just like to give you a few examples from Unpath'd Waters. The UK marine area is enormous compared to the terrestrial area. It's something like 3.5 times the size. And so it gives us a huge amount of scope to work with our collections. And the collections they include vast inundated prehistoric landscapes. So right across the southern North Sea, people once roamed and lived and settled. 250,000 wrecks, a broad estimate in UK waters. That's just the English bit, and that's just the bit that the Hydrographic Office has surveyed, 5,000 of them. I think about 60 or so are protected under law. Archaeological sites. This is Dunwich, the modern coastline is there. This is all under the water. Much of it has been eroded away and no longer exists, but a significant amount of it still survives under there. And we have collections upon collections upon collections. So we have artifacts, wrong one, artifacts, charts, cores from the seabed, side scan sonars, volunteer collections, and so on and so on. So I'm going to give you 3 innovation case studies based around what Unpath'd Waters has been doing with these collections. The first one is around transforming marine heritage management. At the moment, there are 4 national marine inventories. There's Covline in Wales, there's Canmore in Scotland, there's the Heritage Gateway, which provides access to some of our marine stuff in England, and there's the Herone, which is the Northern Ireland dataset. And I'm very pleased to say that as of today, we have been able to put into public domain for testing the integration of those 4 collections, which has been no mean task because they all have their own histories and they're all set up in different ways. And there is the path, there is the URL at the bottom there. So please do, if you are inspired, have a go and have a search. But it goes beyond that. So researchers can now look at the kinds of vessels that might be wrecked under the seabed and so on across UK waters, whereas before they might have had to make 4 different visits to 4 different collections. But it's been integrated into the European aggregator Ariadne Plus as well, where it joins another 3.8 million records as part of the digital collection. We're only halfway through the project, but we're beginning to gain real traction. And finally, it's been a catalyst for one of our partners, the Isle of Man, Manx Heritage, have decided and now have completed the ingest of some 2,000 wreck surveys undertaken by Adrian Corkhill as a volunteer diver. And that has now been ingested into the Unpath'd portal as well. So 5 nations, 4 UK nations and the Isle of Man, now all joined together. Innovation number 2, it'll help us to identify and to manage the historic wrecks on the seabed. This is combining environmental science collections, so we're crossing disciplines here. We're going to look at oceanographic kind of data, seabed data, and so on. We're creating digital terrain models for these wrecks, and this one is just, you can see the wreck there, and these vast sand dunes, mobile sand dunes on the floor of the Irish Sea. Drawing in institutional and archival material, and this is going to provide us information. It's about final resting places of people. These are wrecks that we know are there because they've been surveyed, but we don't know which wrecks they are. They may well be military wrecks, they could be war graves, and they could be passenger vessels. A good example of this is a candidate for the HMS Champagne, this one here, collected from a photographic collection. There it is, having been torpedoed by a German U-boat in the First World War. And we don't know that that one is the HMS Champagne, but AI is going to help us bring together all of the information so we can test its construction, its materials, its size, where it went down, and so on. And we can also look at condition. So this is a survey of the SS Derbent in 2018. That's when the MOD Salmo and Waves group surveyed it a couple of years later. And there is the difference. And AI can compute that difference. This is quite important because some of these wrecks have unknown cargoes, possibly hazardous. So this is not just heritage, this is heritage informing environment. And we can go further than that, and we're going to. So these are the ingests, for example, of UK Hydrographic Office's data on on tidal direction, tidal range, water depth, and so on, which help us to think about lost vessels and their identifications. But they also help us begin to develop a preservation potential map. So we can begin to look at those wrecks within their environment and think which ones are going to survive the longest. And that helps us to begin to think about how we manage those wrecks, which ones we shouldn't fight the battles over, which ones we ought to try and protect or even investigate and excavate. And finally, a third innovation, marine planning. This extraordinary diagram is the planning regime for the North Sea in terms of renewables, offshore renewables. And this is the area sat over those prehistoric landscapes I spoke about. It's very costly to go digging in the North Sea. And the requirement for us to be proportionate and make a good approach to developers to invest their money in looking for archaeology means that we need to target that investment very carefully. So what we're doing in a Unity engine is a dynamic model of the southern North Sea from about 12,000 years ago right up to the present. And this dynamic model, here's an example here, just a snapshot of it. That's the coast of Yorkshire, the southern Yorkshire coast. And these landforms here are all under the North Sea and have all been detected through seismics from the oil and gas industry. We're busy building the Ordnance Survey map for the North Sea from these collections. And this is important because we can begin to develop predictive models of where people would have liked to hunt, to fish, and to move. And this Unity engine that we're building is going to be publicly accessible to allow kids to play where do prehistoric people want to go to hunt for their food or to harvest plants. And this is just an example of the needle in the haystack problem that we have. This is a prehistoric flint found on one site of a now long-lost river well beneath the North Sea when the coastline was where the coastline was about 8,000 years ago. So those are the kinds of innovations that we can begin to accelerate and build when we start linking together, the collections together. And if you want to find out more, we have a project website where you'll be able to look at more of the work that we're doing. Thank you very much.